Hello, everybody. Nice to see you all. This is going to be very much opening up the discussion and showing what's going on inside from one telco's perspective of what our transformation journey is going on right now. I'm going to cover some of the premises of what drove us to be doing what we're doing, and then get more into the meat of what we're doing. And rather than talking about the, I don't have a mic today, I've got to remember that, I've got to stay near here. Yeah, well, you probably can hear me anyway. Rather than focus on too much of the technology and the pipes and the ports, but maybe spend a little more time on our thinking around the digital transformation and the network as a service component, as per the speech. So a little bit in terms of history of, if you cast your mind back maybe 5-10 years ago, we had this situation with a lot of our customers we saw where they started to go to use the hyperscalers for their front end of their systems for their B2C, business to customer interfaces, as they started moving from their monolithic environments, their monolithic stack. And by and large, that was a great success for them. And then it became very much a keeping up with the Joneses, or the neighbors down the street, is every CEO and every board, very much like you can't go anywhere today, anywhere near your board, without them asking you a question on AI, generative AI. Historically, 5-10 years ago, you couldn't really go anywhere to a board without them asking you a question, what is your cloud-first strategy? And so they did embark on that. So, that front end is great in the cloud, so let's put everything in the cloud, irrespective to the reality of that. So I would call that, what we went into this sort of phase, as you may remember, what I would call the great replatforming, where there was these tremendous amount of initiatives where we said, often people would say, oh, by the end of the year, or we'll have half our IT estate in the cloud. That was 10 years ago, 5 years ago. Move the dial forward, and they wonder why they still have that toxic tail. And obviously what they found was there's generally a lack of development skills. There was issues around application performance, resilience, fragmented operations and security. And then more and more, you start to see the regulation and data sovereignty requirements that are complicating the situation. But the biggest one was the biggest truth was this sheer enormous inertia of the legacy code that needed replatforming, and the fact that the business case wouldn't always necessarily stand up to do that. So what we really found when dealing with customers, because I sit on a Monday morning on these incident bridges where the complexity of taking these monolithic clouds, if you remember from a trouble resolution perspective, when you had a monolithic app in your data center, the developers would probably know the name of the top of the rack switch. And when there was a problem, that developer, say you do a push on a Saturday night, on a Sunday morning you could call up those network department, the developer could call up the network department, get onto that switch, get onto that router, and start counting packets in and counting packets out and figure out how to resolve the problem from that perspective. What's happened though, the reality is, and they might even know the load balancer that sat in front of it, but since then we've taken those monolithic apps and exploded them. And you might have still a database sitting in the back end on a mainframe with some middleware, some third-party information, or an additional database sitting in private cloud with a modern microservices front end with very idiosyncratic flows running in between them. And the reality is that most customers' DevOps environment, they've broken the relationship between the application flows and the understanding of the underlying physical topology. And from an assurance perspective, having a non-deterministic network vastly complicates things. So the reality is that we found is that we entered that age of cloud complexity over the last couple of years, and now people are looking to come out of that being a lot more nuanced in terms of their decisions. And here's another sort of oversimplification on how we use it by way of analogy. If the customer is sort of on the planet, at the customer edge, we view cloud now, and multi-cloud from my perspective, is essentially, it's a collection of distributed workloads, right? And obviously, the closer you are to the customer, often the cost is higher, the greater the gravity is, right? On the customer edge, you have to have a pretty special business case, but your cost per workload unit or compute is particularly expensive. So is today having mobile edge. You know, you look at wavelengths with BT and others, it is a brilliant product, but however, it is higher than what you would pay in AWS data centers per se itself. So you're paying for that latency, that customer centricity, or the proximity, should I say, rather than centricity. And then obviously from a service provider, the CNF edge, the other people would call it carrier hotels. Yeah, the sort of the hyper, some of you who are internet exchange people in this room, you know, at the internet exchange, that hyper interconnected location where all the ISPs and all the mobile providers and all the service providers and the hyperscalers peer. Now that workloads there are intensely important to service providers who are doing service insertion for overlays. And then, of course, you've still got the data center edge. And over time, these planets that you see, or these moons are around, either planets around the sun or moons around the planet, it depends on how you want to look at it. You get further out, and then you've got these further ones out with the hyperscaler, and then there's future ones where we have compute and satellite as well. You're going to see the relative scale of where their workloads, they've moved back and forth over years. We actually have a build that shows at one point a lot of the compute for apps was actually at the customer edge under people's desks, right? And then they moved it to the data center to get it out from those desks. So that planet grew, and then eventually we're growing it on this side. So we actually have a build that's rather interesting to show over time, but we don't have time to cover that today. But essentially, this is to sort of just get across the thought. We were thinking, well, if customers are becoming more nuanced in their decision making, and financially they're starting to look commercially, they're looking at a scenario where, you know, this stovepiped approach of TCO is they're moving beyond it. And our thesis over the next 2 years in particular, this concept of holistic calculation of value is going to become more and more a thing. And you're seeing it with these startups. You heard of the concept FinOps, right? You know, there's various different ecosystems around FinOps. Some of them are about cost arbitration, where there's existing workloads being resold. There are stop-loss applications that are, you know, turn the dripping faucet off at night so you don't get bill shock at the end of the month. But you also have this concept of, you know, this argument, oh, do you put it in the public cloud or private cloud? We're agnostic in many ways. Our thesis is let the app decide, because there is a propensity of where you put that workload. And, you know, in the previous slide, certain apps have a propensity as to where they sit in this distributed solar system of workloads. And therefore, if you have it, you know, if you would observe that you have single apps now in multiple locations here, distributed, to deliver a single outcome. And you have developers from different teams, occasionally with idiosyncratic, not necessarily understanding the impact of the network. And if you remember in the data center, you know, what did you have in the data center? You had almost infinite bandwidth. You had great control, you had great visibility, and you had great microsegmentation. But the wide area network, our thesis is, the wide area network now is performing the function of that data center LAN. And it's being relied upon in the same way. So our thoughts was, well, in terms of a network as a service, the fundamental replumbing and architecture of this to be relevant for the next 10 years was to start to consider it as rather than a data center fabric, but to have the wide area network treated as a fabric and be relevant for the future challenges. As the reality is, the wide area network is taking the load of what that data center fabric was when it was a monolithic app. And there has been I think we can all agree there's been a distinct gap between the hype of SD-WAN and other technologies, between the realities and the complexity has gone up and up and up over the years. So our thoughts was, how do we start to at least try to be relevant and reduce some of the friction of moving these workloads and operating these workloads in a distributed fashion? So getting back to the commercials, small point on this, and we don't have time to cover it in great detail, but there's a lot behind this, is that you look at procurement managers today in each of these towers, and they have different KPIs. And often when they make procurement decisions, the outcome, they may be high-fiving for saving 5% savings by commoditizing a particular access circuit purchase, but they've increased 15% pain somewhere else. And you have these towers where you've got individual stovepipe teams moving the pain bubble around. And it is our thesis that in order, and it is a challenge for us in BT because, of course, the sales motion for a holistic value of a combined TCO of cloud and networks and infrastructure and looking at it in a holistic way, you can't have that sales motion like you sold in the past. You can't necessarily win that conversation with the network procurement manager. You need to elevate it to the person who has the single cost center. And that's often to the CIO or the CFO. And this is a much more elevated conversation. So it's a journey that we're going through as well as part of redefining what the network as a service is. These are some of the fundamental building blocks, or the truths that we believe to be true. These are our beliefs that is driving some of the building. So I'm going to stop there on sort of setting the scene and get into what the heck it is. This is definitely a slide that our marketing team have pulled together. But essentially, let me start real talk for a minute. Any telco that tells you that there isn't somebody in the background that is running their operational lead to cash process, that they aren't running it with a spreadsheet, is a liar. Right? Because somewhere in some team, possibly offshored, this beautiful end-to-end process, there is somebody there sitting with a spreadsheet. And that was actually, the technology is the easy part. The digitalization is the real journey that it takes. And moving from a managed service to a network as a service, where we put the control and the visibility and the transparency and not lock in a customer for a 5-year contract and allow a commercial model that is agile as a customer's business needs are to burst up and burst down is a real challenge. And of course, having optimized connectivity and having a deterministic network is super important, which I'll talk a little bit more. But also what we found in the building of what we're doing is, in the plumbing of the internet to cloud, there was some fundamental design issues in the core of how we work things, that we'd forgot the principles that we used to apply and cleave to when we worked with data centers. So we talk about resilience, but we don't necessarily always look at every hop on diversity. And without diversity, there's material impacts to customer experience. So one of the things that we did was made a major CapEx investment around the world to be fully diverse in every availability zone that the 3 major and many others have around the world in terms of the investment, as well as digital orchestration, which I'll spend most of the rest of the slide on. And then, of course, the implications of building a new network and collapsing 4 or 5 stacks, MPLS, internet, ELAN, E-line, service insertion layer, digital front end, abstracting the core. Here's some of the building blocks that we had to build in terms of requirements of what we considered when we rebuild. Here's another one about requirements, another truth that we know to be true. Telcos are very good at repeating the last platform's features on the new platform. And we spend an inordinate amount of time just repeating the previous features. And my feelings around this one was, don't wait for another 2 years. So you do the heavy lifting, you spend all your budget just to replicate the features you served your customer before. And then it's going to be years from that point on before you start thinking about new features or inventing the new art of the possible. From our perspective, we tried to disrupt that and start from the ground up. And this is the first time, this is for us, this was a once in 10 to 20 year CapEx investment to rebuild our platforms from the ground up. And the implications of rebuilding that up, by the way, the new network to deliver, in some cases, 10x performance, the new platforms, by converging this, is using about 76% less electricity around the world. And we are a very large user of electricity. And that was a happy outcome that we didn't necessarily contemplate at the start, but it was one of the outcomes from that. So if you think about the layers of what we've got here, is you've got the network layer, which service providers are great at. This is what we love. And there's many features there that we won't have time to go into. And then there's the stack behind it, the value IT stack. And I'll talk about quite a lot about that. And then the digital experience layer at front, which is actually quite different as to what we've ever done before. And we've designed it from an API first perspective this time, which is something new for us. The functions in basic sense is you have your capillary network. And the building blocks of this network as a service platform is it is a multi-service edge. Yeah, we don't care if you want to connect now, whether it's Ethernet or Internet or MPLS, because it's a multi-service core. We serve it all collapsed onto one infrastructure now at this point. And we've abstracted the concept of the port from the protocol. So you end up with highly efficient horizontal scaling of your network routing infrastructure because that port stays sticky for the lifetime of that contract, of that customer's relationship with you. Whereas today, if a customer has a site and they have 2 MPLS circuits into that customer's site, they wanted to change that site, well, that's okay, we can do that to, say, Internet. But there's very likelihood you'd have to go into the database of one old system, delete that record from that database, do a full cease, then send somebody to that exchange to go and plug from the rack that serves the MPLS and go rewire it and plug it into another rack that is serving Internet physically. And you do a full cease and reprovision. Now, because we've abstracted the concept of the port and the protocol, so this is software-defined underlay, sort of stealing the ideas of software-defined overlay. And what it does is allow us to, on demand, bring more bandwidth or change the protocol, which is something that hasn't happened before. Moving on. I talked about resilience at the head end. We don't have time to go into many of the details today in terms of the technology. But suffice to say, we've really focused on designing from the cloud back out, whereas today most telcos design cloud as an afterthought. They still have their old POPs. Their old POPs were designed in an age when the data center was the center of the universe. Now the data center is not the hub. It's sitting on a spoke. And the hub is those hyper-connected carrier-neutral facilities. And we've relocated. We had a real estate issue. We weren't just replatforming, we were relocating our locations to be at the doorstep of the cloud, at these hyper-interconnected exchanges. But not only that, that we wanted to make sure that if there was ever a failure within cloud, within the networking, either on the cloud provider side, over on this side, or in one of the CNFs, you could still fail within that region rather than falling out of that region. Because and that's what happens today. If you have a failure, by and large, you'll probably be falling out. Your resiliency plan is to fall out of into another region. And if that was, say, a Japan situation, falling out of that, the next nearest region would be Singapore. So you go from Japan to Singapore, land into, say, Azure, then you'd have to tunnel back by the hyperscaler's backbone, go back to Japan, get to your workload, come back to Singapore, come back out, and then come to your workload. That's probably 250 milliseconds round-trip delay. With the new architecture that we designed, it's about 3 to 5 milliseconds delay. And so, you know, when I talked about us forgetting some of the bottlenecks or some of the diversity aspects, that's what we've tried to design in terms of the new platform. And of course, scale. It's a massive CapEx investment around the world to be the best interconnection fabric. So let's get in, within the last few minutes, a little bit around the NaaS. So this starts to talk about the dichotomy of service provider versus the digital experience. Combining these, you start to get to a network as a service. So obviously, service provider trust, you've got the resilience and the SLAs that you can truly trust because they're built from an engineering, unlike many companies, rather than engineered, they're not a commercial SLA where they're engineered from the top down. They're actually, they're provable. Yeah, they've actually been engineered and they're supportable rather than a commercial SLA. That you've got that data sovereignty and security, and you've got that single throat to choke in terms of service, which simplifies things. However, what service providers have not been good at is being commercially flexible, scalable and elastic, and digital and cloud native. You know, remember that spreadsheet doesn't really contemplate service changes within 60 seconds. And that's been a big journey for us. So what have we done around there? Well, what's in the scope? Well, these are some of the scope areas that we started to digitize across there. And I won't spend much on that. I'll let you take a quick picture. As soon as everybody's cameras are down, then I'll move on. And so, you know, this is sort of the build out on how we approached it as well. So, you know, get the learn done, get the buy done, get a light marketplace to test with our customers, get the full dashboard going. And by the way, the dashboard was built on the APIs that we are going to expose for our customers. Originally, the thought within our digital team was, well, we'll have one set of APIs for our internal tools, and we'll, as an afterthought, do APIs for our customers or our partners. We decided to go API first, so we developed the APIs such that our portals and our internal consume those APIs. And then, of course, we also, for those customers of ServiceNow, which I have a slide on each of these areas. So as we get into more of what are the sort of models and how you get into this network as a service. So there's the portal with the web interface, with the apps. Create your own solution demand, real-time modifies and ceases, searchable inventories, operational dashboards, port and service monitoring, subscribe. So the model is more of a pub-sub model as well, which I'll talk about in a minute. But what this doesn't show in the richness of the relationship is today you'd go to your account manager and ask for something, and they do design for you, and then they come back, you know, a couple of weeks later, if not more, with a quote. In the new model of what we're launching is that cost is transparent. So you can do your designs online and do your what-if scenarios and model that out so that you can do your own budgetary proposals internally and run scenarios that are different, because there's not different topologies use different amounts of electricity. They attach a different cost to cloud consumption in terms of egress. and they also have different models from that side. So what we haven't been is transparent and easy to do business with in the past, and this starts to move that away. So there's a much richer set of powerful tools. Like, for instance, you can start to decide where you want to land to your various cloud services or your SaaS services. And within a single city, we can say, well, these points of presence that are interconnected to those SaaS providers, we're doing real-time monitoring of that SaaS provider. And we'll say, well, look, Microsoft Teams, there is a 3 percentage point improvement of stability of Microsoft serving to that POP over there in this city than this one over the last year. So we're actually monitoring operational stability because all infrastructure is not created equal. So there's additional application transparency of performance and historical performance that we will bring to the table that you allow you to make informed decisions when you build the network. And that closes the gap of that holistic view of not just the network team here and the dev team and the apps team over here. It's more of a NetSec DevOps single unified field of skills. Another model is we've got these set of REST APIs that are designed around the product. And they're set of microservice-based, high-performance. Internally, we use TMF. These are very high-performance ones. We have an Apogee external proxy. And also, there's a pub/sub Kafka gateway where you can subscribe to the events. But now if you think about creating applications in the future, if you just want inventory on where your application flows are going over or inventory in the network, to create applications, you can query just the inventory aspects. So you can build apps. Your dev environment can now query and interact with the network APIs and make that information a lot more transparent. And then, of course, you have the toolkits and go from there. That's the second way of interacting. The first one is the GUI. The second one is a fully API one. And this API stack is powering the GUI, by the way, as what we talked about before. And then start to get a view. You know, we've really tried to make it super, super easy to consume and build with our partners because we believe that this is an ecosystem play and a scale play. And the more we have our fabric interconnected with other fabrics, the better. And then the third way is much of our big multinational customers are ServiceNow customers. So having that API interaction with Service Bridge and other aspects there, basically publishing our catalog into ServiceNow is another way for people to trigger workflows on network changes and interactions there as well. I'll just wrap this up with just checking the time. Yeah, we're just towards the end, but a couple of other things that you can start to control in the network once you make it fully programmable. If you think about business intent, and people have been talking about business intent, the way we look at business intent is a set of geographic constraints, performance constraints, and diversity constraints. And we apply that to our network services, whether it be IVPN or ELAN or internet connection. You know, remember, the internet today with data sovereignty, what does that give you? These are the sort of programmable interfaces for a network interface program now that you're talking about. Now, if you think about it, how do you manage the paradox of a regulatory environment that previously only looked at data sovereignty for data at rest, and they've started to rule that you need to have your data sovereign in motion, but you're using the internet. But the paradox of the internet is not geographically knowledgeable. So how do you reconcile those two facts where the internet was designed to sort of survive a nuclear war with DARPANET? And we'll find another way to do that. So you could be in Germany where you have a regulated set of data in a regulated data center, that's great, but your primary ISP has a failure on their trunks and they reconverge via Russia. How do you start to reconcile against that? And we believe we solve for that. So our internet now has the metadata and the controls where it is geographically aware. And because we've abstracted the path computation, because you remember the old MPLS, you'd compute your next hop of your path at every node that you'd do. Now we've abstracted that control, so segmented, routed underlay. And we will be able to enforce. So imagine you could consume a network as a service, an internet, but say for these particular application flows, I would like them to stay in the UK and never leave the UK. Or I would not want any of these packets to go via the US. And believe me, there are some customers who would like that not to happen. I can leave you to guess why. And so you not only can you do geofencing, but you can also do no-fly zones. And you can do other things as well with the controls, as you can see there in terms of the controls. You can also do things like, for extra high resilience, you can do disjoint paths and control that there is no single point of path. And think about SD-WAN providers. SD-WAN providers have smart path control, yeah? And they're great, you know, PFR, but often it's only the first hop. And it's flapping between one crap flavor of internet and another crap flavor of internet, yeah? Now imagine if you had that control and you had a closed loop automation between your overlay and your underlay, and actually you extended that path control to every hop of the journey end to end and controlled it from that, all part of a network as a service. So these are some of the things that we're solving for, not just for now, but having a platform that we solve in the future, and it is a digital platform and it's as a service that it is controllable. And one of the premises of network as a service is not just the flexibility of the commercials, but also the flexibility of being able to inject business intent into what was previously a black hole, right? The core of a service provider network, you never got anything out of it, and it really didn't know what the customers did. It was just moving packets around with tag switches on it, and we've stopped on that. So I'm going to stop there and open up to questions with the couple of minutes that we've got left, if we've got any minutes left. But thank you for your time. Right.
So, has anybody got a question for Colin? I'm trying to imagine everybody's got a couple of dozen, but anybody with a quick question? No, you all too stunned after lunch with that. Okay, well, the really good news is, that's gentleman here.
Okay, I thought I got away with it.
It's obviously come around more quick after lunch.
Colin, thank you so much. Two quick areas to look at. One is the legacy, how you deal with the legacy. Legacy, either like it is hardware, processes internally. Yep. And then the second is that actually you need also a change of culture as well, right? So culture of people, right? So how you dealt with that, or how you envision this in the future? Thank you.
Very quickly, so legacy, there's a dual run cost. So we have 211 legacy POPs that are not in the locations that ultimately our new POPs will be. And we're building out another 160 core POPs. So we ramp up to about 370. And we actually tether the old POPs off the new POPs so that the transit costs of all the transit subsea circuits are running off a new, so there's a core within a core. So all new customers get connected to the brand new core. And then we do run in the meantime, and ultimately in a number of years, we'll be migrating people off, particularly as we get to end of service life for the legacy side. From a ESG perspective, from an energy usage perspective, the legacy platforms are far more inefficient than the new ones. And if you think about it, in the UK, the energy bill for us was an additional 200 million last year, just in energy costs. So you can imagine how we're motivated to migrate from the old to the new. That's not per se, that's all the PSTN network as well. So you can see why the All IP project is running. I've got it simple on the international networks, only layer 3 and layer 2 rather than the physicals. But either way, we start to take the brain parts out with concentric circles to deal with the legacy as soon as we possibly can. In terms of culture, I think I spoke to it. I think technically, the technical teams, I've been incredibly proud of the technical teams cleaving to this and adopting to this. You know, I haven't really seen any problems on that side. I think the problem we've had was maybe getting the digital teams to understand networking. I haven't seen as much trouble with the networking teams yet. Maybe I'm just naive of the network teams not appreciating digital. But it's, you hire off the street somebody who's never done anything with it. You have to find a way to marry the teams up, but that's a skills and a learning side. I think the bigger challenge has been the sales cycle. So hopefully that answers your question.